Hi class, my name is Caprice Van Den Eekout, and I'm going to be substituting our class today, and we're going to be going through a few important topics involving geometry, and I'm really going to try to go through step by step and explain each and everything, and by the end of it, I really hope that you guys are able to retain the information and understand it and be able to execute it on your own. So yeah, I'm going to go through some really important key concepts, and we're going to be using a lot of strategies to be able to conquer each and every equation. So let's get into it. Okay, so number one, we have our triangle congruence, and we're using the side postulate. So what we have given is ABC with sides 6, 8, and 10, and DEF with sides 6, 8, and 10. Our solution steps are going to be compare the three pairs of corresponding sides. So AB equals DE equals 6, BC equals EF equals 8, and then AC equals DF equals 10. We can see that all three pairs match. If all three sides of one triangle equal the three sides of another, the triangles are congruent by SSS. So we can see here they match. So ABC and equals DEF by side. Okay, so we have angle similarity from given angles. So in ABC, A equals 40 degrees and B equals 65 degrees. In DEF, D equals 40 degrees and E equals 65 degrees. So are the triangles similar? So our solution steps are going to be comparing the angles. So A equals D equals 40, and then B equals E equals 65 degrees. So we can see that two pairs of angles match, so triangles are similar by the angle theorem. So the third angle must also match because triangle angles sum to 180 degrees. So our final answer is ABC and DEF by AA similarity. We're going to go down and we're going to go to this problem. So angle bisector creates similar triangles. So in the problem, we can see that ABC and angle A is bisected by AD, meeting BC at D. So we have to prove that AB and D is equal to AC and D. So BAD equals DAC because AD bisects A. And ABD and ACD are vertical corresponding angles in the smaller triangles. So two angles are equal, so that makes triangles similar by AA. So the final answer is ABD and ACD are equal by the angle theorem. Okay, so now we have another problem. We have triangle congruence, which is angle side angle. We're going to be using that postulate. So x equals 40 degrees, and then y equals 65 degrees, so xy equals 7 centimeters. P equals 40 degrees, Q equals 65 degrees, so PQ equals 7 centimeters. So two angles and the included side match between two angles. So x equals P, y equals Q, and xy equals PQ. So when two angles and the included side are equal, triangles are congruent by ASA. So XYZ equals PQR by the angle side angle postulate. Okay, so the next one is dilation with scale factor less than 1. So our problem is we have to dilate B and -6 and 9 by K equals a half about the origin. So the solution steps are going to be multiplying each coordinate by a half. So B equals -6 times a half, and then 9 times a half, and then B equals -3, 4.5. So our final answer ends to be -3, 4.5. And you figure that out by using this right here and just multiplying the coordinate by a half. Each coordinate by a half. So then we have dilating a point on the coordinate plane. So dilate point A, so the problem is going to be dilate point A for -2 by a scale factor of K equals 3 about the origin. So our solution steps are going to be multiply each coordinate by 3. So we have A equals 4 times 3, and then -2 times 3. So A equals 12 and -6, and that is our final answer. And I hope you enjoyed the duration of the class, and I really hope I was able to thoroughly go through everything and kind of undercomplicate things if you maybe had a hard time understanding them. But yeah, I hope you guys enjoyed and have a good Christmas break.